Hi, I'm Nicholas Gaudern and I'm the CTO of PowerCurve, and in this video I'm going to talk about trailing edge serrations, what they are and how we can use them to reduce wind turbine noise. Now, the dominant noise source from a wind turbine comes from the passage of the blades through the air, and that's that swooshing sound. And as turbines have got larger and larger, the noise has become more of a problem on some machines. The reason for this is that the noise from an aerofoil scales with the fifth power of the local velocity, and this means that as our turbines get larger and tip speeds increase, the noise is going up by that fifth power, which is a really large factor. So an aerofoil has a suction surface and a pressure surface, and when we reach the trailing edge of the aerofoil, this pressure differential causes a vortex to be shed from the trailing edge, and it's the size and strength of this vortex that determines how much noise a wind turbine produces. Depending on local regulations and the proximity of turbines to housing, it may be desirable to run a turbine in a low noise mode, and that often means curtailing production. Obviously this has a huge effect on annual energy production, and it's much more effective if you can address the problem of noise by attacking its source, i.e. the aerofoil. This is a PowerCurve serration. This is a 3D printed example that we use for wind tunnel testing and other development purposes. It sits on the trailing edge of an aerofoil, and it changes the vortex shedding mechanism that occurs at the edges of the blade. Now, if we carefully control the shape, size and angle of these triangles, we can modify the frequency spectrum of the emitted sound, and by doing that we can reduce the overall sound power level of the turbine. PowerCurve serrations are designed to be load neutral, which means they will only reduce the noise of your turbine and not increase loads or reduce annual energy production.